Math 1143, Section 3.2, Exponential Functions. We're now on Objective 3, use exponential functions to compute compound interest. Suppose a principal of P dollars is invested at an annual interest rate of 100R%. So the decimal form of the annual interest rate is R. For example, if the annual interest rate is 6%, then the annual interest rate in decimal form is 0.06. If interest is compounded once a year, then determine the value of the investment after 5 years, and then determine its value after t years. Okay, so when we start at year 0, P dollars is invested. After 1 year, well, we still have the P dollars, but we also have interest that is added to the account, and that's R times P. Notice that you can factor P out of both of those terms and write it as P times 1 plus R. And then after the second year, we have what we put in, or we have in the account what we had at the end of 1 year, which is P times 1 plus R, plus R times P times 1 plus R. This is the amount of interest that was earned during the second year. And notice that we can factor P times 1 plus R out of each of those terms. And so we can write this as P times 1 plus R times 1 plus R. But we can write this as P times 1 plus R to the second, because 1 plus R times 1 plus R is 1 plus R to the second. Perhaps now you see the pattern. After 3 years, the value of the investment will just cut to the chase. It's going to be P times 1 plus R to the third power. And then at the end of 5 years, the value of the investment is P times 1 plus R to the power 5, to the exponent 5. And then after t years, the value of the investment is P times 1 plus R raised to the exponent t. Okay, this is one of the compound interest formulas, and there are others that we will take a look at. For now, we'll define the variables involved. For compound interest formulas, capital P represents the principal. The principal is just the amount of money that is invested. Lowercase r is the annual interest rate in decimal form. N is the number of times interest is compounded each year. And T is the number of years since the initial investment. Okay, so the compound interest formulas are as follows. The value V of an investment after t years is P times 1 plus R raised to the exponent t if interest is compounded once a year. This is the formula that we derived on the previous page. If interest is compounded n times a year, then the value of the investment after t years is P times 1 plus R divided by n raised to the exponent n times t. And then if interest is compounded continuously, the value after t years is P times e to the exponent r times t. Okay, so we'll use the compound interest formulas to write down the value of a certain investment after a certain amount of time with a certain interest rate. So in this problem, suppose $8,000 is invested for 11 years and the annual interest rate is 6%. Find the value of the investment if interest is compounded annually. Okay, so the value of P is 8,000, so the value is 8,000. The interest is compounded once a year, so it's 1 plus 0.06 raised to the exponent 11 because its investment life is 11 years. On this one, it's easy to simplify what's inside the parentheses. You could write 1.06 on the inside. If interest is compounded monthly, that means 12 times a year. So the value of n is 12. So after 11 years, the value of the investment is 8,000 times 1 plus 0.06 divided by 12. And the exponent is 12 times 11. This is the n times t. The exponent can also be written as 132 if you like, but we'll just leave them in unsimplified form for now. If interest is compounded quarterly, that means 4 times a year, once every 3 months. So the value of n in this case is 4. So after 11 years, the value of the investment is 8,000 times 1 plus 0.06 divided by 4. And the exponent is 4 times 11, or 44. If interest is compounded daily, then the value of n is 365. So after 11 years, its value is 8,000 times 1 plus 0.06 divided by 365. And the exponent is 365 times 11. Okay, if interest is compounded continuously for 11 years, then the value of the investment is 8,000 times e to the 0.06 times 11. Okay, on the next page, we'll try to see if we can use the information given to find the annual interest rate. So in this one, we're told that the value of an investment of $7,000 increases to $11,000 in 9 years. Find the annual interest rate if interest is compounded annually. Okay, so if interest is compounded annually, let's write down the function for this investment first. After t years, the value of the investment is 7,000 times 1 plus r to the t. We don't know what the value of r is yet. That's what we're trying to find. Okay, but we're told that this investment of $7,000 increases to $11,000 in 9 years. So when t is 9, the value of the investment is 11,000. So we will replace v with 11,000. We set that equal to 7,000 times 1 plus r, and we replace t with 9. Okay, we want to solve this equation for r, and we know enough to be able to solve this for r. First, divide both sides by 7,000. And note that when you divide 11,000 by 7,000, it's just 11 over 7. So 11 over 7 equals 1 plus r to the 9th. And then if we raise both sides of this equation to the 1/9 power, so the left-hand side will raise that to the 1/9. And the right-hand side, 1 plus r to the 9th, we'll raise this to the 1/9 also. And the reason we chose to raise both sides to the 1/9 power is because using one of the properties of exponents, 1/9 times 9 is 1, and 1 plus r to the first power is just 1 plus r. So now we can solve this equation for r just by subtracting 1 from both sides. And so r is the number 11/7 raised to the 1/9 minus 1. Okay, the next three examples just involve different values of n. For monthly, we would use n equals 12. For quarterly, n equals 4. For daily, n equals 365. So I'm just going to do the one for quarterly. And the other two could be done by mimicking this one, just replacing n. Okay, so the function, if interest is compounded 4 times a year, then the function, or the value, is 7,000 times 1 plus r divided by 4 raised to the 4 times t. Okay, but we're told that when t equals 9, the value of the investment is $11,000. So we will replace v with 11,000 and set 11,000 equal to 7,000 times 1 plus r over 4. And we're also going to replace t with 9. 4 times 9 is 36. And then we'll solve this equation for r. So just like we did in the previous problem, we divide both sides by 7,000. 11,000 divided by 7,000 is 11 sevenths. So we get 11 sevenths equals 1 plus r over 4 to the power 36. And now we're going to raise both sides of this equation to the 1/36th power. On the left-hand side, we'll get 11 over 7 to the exponent 1 over 36. And when we raise the right-hand side to the exponent 1 over 36, we're just going to be left with 1 plus r over 4. Okay, so in 2 more steps, we can solve this equation for r. First, subtract 1 from both sides, so we get 11 sevenths to the exponent 1 over 36 minus 1 equals r over 4. And then multiply both sides by 4, and we get 4 times the quantity 11 sevenths to the 1/36th minus 1 equals r. You can use a high-powered calculator to find this number. It's approximately 0.05 or something. Okay, we'll do the last one. If interest is compounded continuously, so if we have an investment of $7,000 and we don't know the interest rate yet, and if interest is compounded continuously, then after t years, the value is 7,000 times e to the r times t. Okay, but in the given problem, if you remember, the value of the investment will be $11,000 when the value of t is 9 years. Okay, so down here we'll replace v with 11,000. 11,000 equals 7,000 times e, and we're also replacing t with 9, so e to the 9 times r. Then divide both sides by 7,000 again, and we get 11 sevenths equals e to the 9r. We can do one more thing. We can raise both sides to the 1/9th power, and we get 11 sevenths to the 1/9th. And when we raise e to the 9r to the 1/9th, we just get e to the r. We want to solve this equation for r, but we see that r is in the exponent. And we do not yet know, well, at least we haven't covered anything in this semester that enables us to solve this for r. But when we start section 3.3 in a few days, we will learn how to solve this equation for r.